Assalamualaikum. My name is Muhammad Faris Salman and I will introduce my team member first. The first one is Ibrahim Ramli. Next is Al Bashri. Then Izzat Izzuddin, Sharif Salim and Zamir Abdullah. And for this group project for NDT, we have decided to choose railway industries and focus on the rails part for this project. So hope you enjoy our presentation and that's all. The objective for this group project is to understand the working principle for the NDT method that we choose for common and advanced method, and we will identify the importance of NDT in each phase and evaluate the NDT result. And next, we will suggest on how to improve the performance of the component structure or system. Okay, for the common method for the railway industry, so we decide to choose the ultrasonic testing, where it is one of the common non-destructive testing, where it uses piezoelectric transducer connected to a flaw detector, and UT also is ideal because it can detect the flaws inside a metal of the railway industry, and it can be performed using two basic methods, where the pulse echo and through transmission, and we will see which one is suitable for railway industry. Basically, there are three basic method for the ultrasonic testing, but we are focusing on the pulse echo and through transmission, where the first one is pulse echo testing, where it will use the same transducer to emit and receive the sound wave energy. But for the through transmission testing, it will use different transducer for emitter to send the ultrasound wave and the receiver to receive the sound energy at the opposite side of the object. And based on my study, the railway industry in India are using the pulse echo for the railway industry for UT. And here we go to the working principle of the railway industry for the UT. And the first step is electrical pulse will be generated by a pulsar, where the pulsar will drive the transducer to produce the high frequency ultrasonic energy, and this sound energy will propagate in the form of wave through the material that we want to check. And if when there is a gap in the wave part which might be caused by the crack, so some of the energy will be reflected from the floor surface, and the transducer will receive the wave and it will be transformed into the electrical signal and projected on the screen. And on the screen, the reflected signal intensity is plotted against the time from the signal generation to when an echo is received in the applet below, and the length of time it takes for a signal to travel is proportional to its distance travel. And from the screen also we will see the data about the reflector's position, scale, orientation and other characteristics in order to know the signal of the crack or any flaw inside the material.
Next is the importance of non-destructive testing. Firstly, the non-destructive testing techniques do not cause any harm to the material itself in gaining information on its performance and structure. Secondly, industry rely on NDT methods to ensure the safety and reliability of their products and component structures. And also, the NDT method can test the materials without destroying the specimen. Thirdly, the NDT methods can reduce the cost because it can do the inspection when the specimen is in service and do not require to shut down the operation. Fourthly, the NDT method is used to ensure the efficiency and durability of the component and equipment.
Onto the result of NDT. For the common method, which is the ultrasonic testing, this method is not suitable for surface or near surface defect, where it will produce a very poor result. This is due to the near field effect, where the signal initially unstable at the surface. This diagram shows some of the defect can occur on the railway track. For example, the time risk cracking, vertical cracking or any crack inclined to the top surface are not detectable by conventional method. For the horizontal surface damage, such as shielding or head check, prevent the ultrasonic beam from reaching the internal defect, which will result in false or negative reading. The ultrasonic inspection can measure the length and the depth of the defect. The length is measured from the distance between the signal, while the depth is measured from the difference between the time taken for the pulse to reach the crack and the time taken for the pulse to reach the bottom of the specimen. Next, for the aluminothermic welding, which commonly used welding method for railway track. For this welding method, after finishing the process, there will left a large material grain size of weld, which strongly shatter the ultrasonic and rise the attenuation and reflect signal that will result in difficulty to interpret the data. For the reading speed of the inspection is very limited, and for the method is need a contact between the rail and the inspection wheel. Other problem relate to this conventional technique is that the transducer must be coupled to the rail for the testing. For the coupled medium, this method can cause a transit time error where the particle transmission and particle reflection of the ultrasonic energy may cause change for the shape of the wavelength, which will lead to error for the measurement to detect the defect.
Next is the suggestion to improve the performance. Firstly, this technique is good for detecting subsurface defects, but poor in surface and near subsurface defects. The probe used can be oriented to the optimal angle for detection inspection, thus improving its accuracy. However, this method is more time consuming. Secondly, ensure the frequency is set suitable with the wavelength, where the wavelength must be longer than the specimen length.
So now I am going to introduce on the advanced method, which is infrared thermography. So firstly, this method is for detection radiation heat coming from an object with a thermal imager. So this device, and then it translates to temperature. Then it shows the picture of the temperature distribution, and the sensors are ideal for inline inspection because they are small and quick response time. So it is very fast and it is easy to track infrared images with sufficient knowledge of radiometry and heat transfer. Infrared energy occurs when the heat is transferred from the surface of the object during emission. This is when the object have heat that release. So this infrared captures it, and then the heat transfer by convection when heated gas or liquid passes of an object. So this process also relates to the heat transfer when convection happens, and also in conduction during the heat flows through the solid body. Next, we move on to the types of infrared thermographic. So firstly, passive involves testing the component during after operation, and this process does not require external sources to work. And active thermographic requires external energy to produce thermal variance so that it will have a different results. And flash thermography measures the changes of surface temperature after a pulse of light. And vibrothermography is a technique that utilizes acoustic waves to find the cracks in the material. And lastly, lock-in thermography requires the external source of energy, example light and sound. So next, the working principle of the infrared thermographic, the way it detects in the railway situation. Firstly, the infrared radiation is emitted by an object with a temperature greater than zero, absolute zero. This is important. Next is however, the human eye is not compatible at this wavelength, so the infrared radiation we cannot read it. So to translate this, we need an object. So the optics in the thermographer calculate the temperature of an object surface and make it visible to the naked eye with infrared radiation. The detector tracks it and translates it to electric signal and assigns a color to each signal, which then will be shown onto the thermal imager monitor to make infrared visible. So, and then it converts infrared wavelengths into visible wavelengths for human, which is between 400 nano nanometer into 14 I mean into 780 I think is micrometer. To check it back. And lastly, this way to ensure that machines operate properly, to identify the, irregular heat variations inside the system that indicates flaws or efficiency in the railway if it's too hot. Thank you.
Alright, okay, moving forward, for the infrared tomography result. In order to assess the detection performance of infrared tomography, the correct material was subjected to thermography inspection. Metallography section were made on some indication in order to check for a defect and characterize it. Picture here shows that there are a circumferential indication detected by thermography. Okay, on this picture, there is an example of a metallography analysis on the indication detected by thermography. It is confirmed that there are a presence of a deep cork shard. As we can see, there are about 325 micrometer in length of a crack. Okay, for this picture, we can see that by using infrared tomography, there are a radial defect can be detected. The same material and the same infrared tomography configuration simultaneously evidence the radial and circumferential indication. Thermography allows defects to be detected in both directions, even if the chosen configuration is better suited for radial defects. The metallography analysis carried out by Patrick Boutel on some of the paper that we researched, from approximately 20 indications, they are confirmed that the presence of a defect for each detected indication. So we can conclude that from this infrared tomography, the results are quite accurate. Obtaining digital images also allows the sanction to be automated. It allows computer-aided detection of indication on images obtained by tomography. This step will make it possible to reduce the manpower necessary for the inspection and thereby to reduce the cost of inspection. Thermography is also an environment-friendly, energy-efficient method which does not require the use of any chemical. Finally, thermography reduces risk for personal health as it complies with European directive regarding operators' exposure to electromagnetic field and solvent vapors.
Okay, now we proceed to the suggestion to improve the performance of this infrared thermographic method. So the original thermal image contains much noise due to the interference of many factors, especially for the defects with large depth or small size. Due to the small temperature difference, amplitude difference, and phase difference, it is easy for them to be submerged in the noise. If defects or damage in the test object exist, the discontinuous structure of the object will lead to the significant abnormality in the surface temperature. If defects or damage exist in the test object, the discontinuous structure of the object will lead to the significant abnormality in the surface temperature. The technology has the characteristic of fast detection speed, large detection area and convenience for online detection. It can detect the defects such as debonding, cracks, rust, fatigue, damage in metal, non-metal, and composite materials. It is increasingly becoming an important means to ensure the product and safe operation. So, what can be concluded here NDT method has been useful to check the flaws or defects on the surface and subsurface of the component or structure. Infrared thermography is a fast, clean, and safe technology because no radiation and easy to read visual limit with real-time output. It is a non-contact method, hence can be used for a large part as it could capture wider thermal image for inspection in one go. Ultrasonic is a contact method, hence it is more sensitive to the surface, which only allow the inspection on the surface it contacted to, and it also consuming more time to inspect one large component. Okay,